Okay, kids, imagine this. The year is 2014 and the place is the Sully Sea region in North America. In this region there live these seagulls, Larus glaucenses, which are really awesome and fun and friendly, but scientists can't help but notice that over the past century their population numbers have been dropping. Why? What changed? Their environment, their diet, their society, their economy? And if so, how can we possibly prove it? Enter stable isotopes, the heroes of our story. So now kids, you might have a few questions. What are isotopes? Why are they in the stables? What do they have to do with the utterly awesome seagulls? Let's answer these questions one at a time. So, first of all, isotopes are variations of atoms of the same element, but with a different mass, due to a different number of neutrons. Still with me? Good. Stable isotopes are simply a type of isotopes which do not decay. This is because they are inside where it is warm, and not in the cold, or something about having a balanced nuclear. Because stable isotopes do not decay, they do not emit radiation. Despite this, they still have many unique properties and attributes and are used and applied in many ways. For example, you guessed it, in environmental studies. Hopefully now you can start seeing the connection to our friends the seagulls. So, back at the problem site, Louise Blight from the University of British Columbia and her colleagues are trying to find out what has changed. They studied 270 seagulls' feather samples, some of them nearly 150 years old, hoping to find traces of their diets. They studied them using stable isotopes. To be specific, the team used the ratios of heavy isotopes of carbon and nitrogen to figure out what the seagull's diet used to be and how it changed. The scientists find a decline in both types of isotopes as the years grow closer to today, indicating that the seagulls abandoned the carbon-rich fish for food on land, and not any food but literal junk as suggested by the heavy drop in nitrogen isotopes. Or as Dr. Blight elegantly puts it, the stable isotope work shows the decrease of fish in diet over the time frame where forage fishes have declined. To simplify, the scientists figure out the diet of seagulls over a century dead using nothing more than the ratio of isotopes left on their preserved feathers. That, kids, is very cool and very scientific. So now we know what caused the decline in the number of seagulls, as the change to poor quality, low protein, low isotope diet is linked to reduced reproductive success in the gulls. We, however, do not know what was the reason for this change. Oh, wait, we do. I'll give you 3 seconds to guess why the seagulls had to change their diet. Humans. Because of humans, the change in the diet, drop in isotope ratios and drop in the population of these magnificent flying wonders directly coincides with overfishing in the region. Even the gull's favorite fish, eulacorn, which is highly nutritious, is now endangered. Again, kids, we must ask ourselves, what are we doing? Why do we keep ruining these wonderful ecosystems? We truly must consider our actions more carefully and act not on the basis of that could we, but instead should we. Harm to seagulls is only a small part of this massive phenomenon. In conclusion, thanks to stable isotopes, we can learn how the environment has changed and how we have caused that change. However, no matter how useful they are at figuring out problems, the isotopes are not going to fix them for us. They are not going to bring the seagulls back to life. The only way we can save future seagulls, even our planet, is to accept what the stable isotopes have shown us, learn from our mistakes and try to make the world a better place. Wonder how you could do that? Like and subscribe! Bye.